Okay, welcome everybody. We're going to be talking about code style today. So let's start with why code style matters. Code is written for the first time at least once, but it's read many, many times. It's also modified many times, and often these modifications are not by the original author. People reading it even if they're not going to modify it, they're just trying to figure out how it works so how they can figure out how to reuse parts of it, are again not the original author. So a key goal in writing code is to write code that's not just correct and performs well, but is also easy to read and understand. And that's a skill that comes with practice. Just like practicing writing clear essays makes you better at it, right? Practicing writing clear code makes you better at it. And you're going to get feedback from your TA in this course, and some marks in each milestone on code style, so you're going to get some feedback on it, which is the other part of how you get better at it. So your goal is to write clear code. And the reason is that code which is hard to read, is problematic for a bunch of reasons. So it's bug prone. If it's hard to reason about, you don't really understand the code, it's likely there are corner cases and bugs that are not going to be found. It's hard to modify. You can't really modify something unless you understand it first. And it's less likely that you're going to reuse it, because if people reading the code don't understand it, then even though it might have solved a problem that's useful to them and they could have incorporated it in some future feature, they won't, because they don't understand what it does. Okay, so you don't want that. And this is really important in industry. So industry does code reviews all the time because code quality matters a lot. As programs get more complicated, they can become essentially impossible to maintain or incredibly expensive to maintain and enhance if they're not well written. So at my startup, and again at Altera, we did regular code reviews where we take large pieces of code and go have various people read it and give feedback. So we developed kind of a team coding style, and we made sure that we could read each other's code and people knew what code was easy to read and what was hard. Google does a very good job of this. Code at Google, you commit code to their source code control system, it actually won't be fully committed, meaning visible to other people and built into their system, until it's reviewed by two other people. One who's an expert in the system you're working in and knows whether this fits into the architecture of the system, and another person who is considered an expert in code style and says, yes, this code is easy to read. And they won't even basically, it doesn't make it into the source code control system until it passes both those reviews, which keeps their code quality high and essentially gives continuous feedback to all their developers on what's readable and what's not. So that's a great way to do it. So that's just examples of how important this is. Companies spend a lot of effort on this. So today we're going to talk about some guiding principles of writing readable code, and then break those down into some more detailed recommendations. So some of those more detailed recommendations have to do with the length of functions, how you name your variables, so give them good, meaningful names, scope, so try to keep your variables limited in scope so you don't have to think about them for too long. And we're going to talk about temporaries. Temporary variables can help readability, but they can also hurt it if you have too many of them. Comments, so you definitely want to have people don't comment enough. So generally you want to comment more than you think is necessary. Avoid duplicate code. And then there are lots of other things that you can do that we're not going to cover. We'll cover some more of those in one lecture, and then you'll keep learning about your own personal style as you write more code. Okay, so guiding principles. So we're trying to reduce cognitive load. Programming requires that you understand a lot of details, and human working memory, the number of things you can really keep in your mind at the same time and be working with them, is quite limited. So there's a famous study by Miller that showed that the vast majority of the population can keep 7, there's a little bit of variation, so plus or minus 2 items in their memory at the same time. And this is actually why phone numbers are 7 digits long. It turns out that people can remember a 7-digit number reasonably well if they try. As you get up to 10, 11 digits, they really can't. So that's why phone numbers are 7 digits long, and then you have area codes, which are easier to remember because you only usually have a couple of area codes in a city, or maybe one. But 7 digits people can remember, 11, 12, they wouldn't be able to remember. So it's the same idea in coding. We're going to try to reduce the number of things that a person needs to keep in his or her mind to make it easier to understand code. You want to explain why. So if you write your code clearly, a person can read it and understand what it's doing, but they can't talk to you because you may not be around, right? You might not be available. They might not know who you are. You might have left the company, whatever. So you're not around to explain. You may not even remember. So I'll read comments that I wrote months or years ago, and they tell me what I was thinking and why I did something that way, and I don't remember that. So it's a message from me to me, and I'm happy that past me sent that message, because otherwise I'd be in trouble. So the code, reading it, explains how, but it doesn't say why. So you need to give that big picture. What's the overall structure? Why am I attacking it this way? What are maybe some trade-offs of that, etc. Okay, so let's dive into how we apply those kind of big picture ideas. So for functions, you want to keep them short. So if a function is long, and it's shorter than you think. So ideally, your functions are 10 lines or fewer long. You can have some functions that are a bit longer than that if their structure is simple, but most people write functions that are too long. So keep them short. And one of the previous tutorials, people asked me, what does this "it smells" mean? It means it works. So maybe we've got a long function. It's 50 lines long. It functions, it passes the test, but it's kind of like opening a refrigerator and there's a bad smell. You shouldn't feel happy about that function. It's too long. How did it get so long? Sometimes people just write long functions, so we want you to fight that habit. More commonly, what happens is it started out short, but a case was found that was missing. So someone added a couple more lines to handle that case, and then a new feature came up and a couple more lines, and then 4 more, another 5. And gradually the function got longer and longer with more and more if statements in it, and it's harder to understand. It'd be better to break it into essentially helper functions. Have a top level control routine that just calls some helper functions so that the helper functions are short and your top level control routine is also short. Long functions are bad because they're harder to read. You have to keep more things in your memory and harder to understand. And they're harder to maintain for those reasons. They're also harder to reuse. Usually a long function does multiple things, whereas if you have a function that calls just a bunch of short helper functions, those helper functions each do one thing, it's much more likely you can reuse them elsewhere. So it helps you avoid duplicate code. Shorter functions force you to name parts of your code. So if I read a control routine that, and when I say control routine, I just mean it's a function that really just calls other helper functions. And each of those helper functions is a good name. I can understand just by reading the names of the functions it's calling, what's the overall flow of this? Maybe I'm doing something relatively complicated, but I can see you broken into 5 steps with these names, and it's self-documenting. I understand what you did. Much better than you had just written 50 lines of code that did it all. So they make you name your code, and your code is better organized and structured, easier to reuse functionality when it's in short functions that do one thing. Okay, variables. You want good variable names. They should describe the contents and the purpose of the variable, so it shouldn't have to go back and look at how you declared the variable and how you initialized it to figure out what's going on. I can do that if I need more detail, but in most cases I shouldn't have to do it. So we don't want to see a lot of variables in your code. We don't want to see this. You got a bunch of I, J, K variables. There are a few cases where, well, I is really not great, but there are a few cases where it's a loop counter with not much meaning where maybe I is okay. But if these are really, one of those is intersections and another one of those is street segments, then we really want to see, inter and street seg and so on, or maybe even longer names than that. Temporaries. So we're going to show some examples of this, but temporaries are kind of a trade-off. You want to minimize the number of variables that you have in scope, so having a lot of temporary variables can conflict with that, especially if the temporaries are kind of renames of each other. So if you have a lot of this, like I equals K, and then J equals K, and so on, where these variables are actually really just copies of each other. They kind of move in lockstep. That makes your code harder to understand because you've essentially used the same, you're just renaming things. Now, if these variables actually do different things, then that's fine, but be careful about just renaming things into different temporaries. Now, some temporaries can help readability. If you had no temporary variables, you might try to do too much on one line of code, and that can be hard to understand too. So we'll give a few examples because this one is kind of a judgment call and a trade-off. And let me actually get rid of all these ink annotations. Looks like I've still got some old ones. So let's restart this. Okay, maybe I can't get rid of the incantations right now. We'll try that later. Let me do a poll here to see what you think of this code style. So read this code. And this code is actually relevant to milestone 1. This is part of a function that will compute the length of a street segment. So a street segment ID is passed in, and it returns a double, which is the length of that street segment in meter. So let's see. Let me launch this poll. So I want you to say what you think of this. Okay, so hopefully you can see the options now. So read through that code and pick an option here. Okay, so I'll give you a few more seconds to think about it and make a choice. Actually, Sage has a good point. So I see Sage in the chat has said he's heard that too many nested calls or Sage considers that too many nested calls is considered hard to follow. And that's a good point. So if every function just did almost nothing and then called a helper function, and then that helper function called another function, and I had to go down 4 or 5 levels of function to do almost anything, then that also can be hard to read. Sometimes that happens when people are doing sort of excessive abstraction. They've decided that every single operation should be in a class that is wrapped in accessors, and those accessors are wrapped in another class with accessors. So you've got a whole pile of abstraction, and to figure out what you're doing, you have to always punch through several levels of calls. I don't particularly like that either. So I don't like adding that much abstraction to my code. So good point. I'm not encouraging you to do that. I'm encouraging you to have shorter functions. Does that make sense, Sage? So it is a very good point. Sometimes it comes from people trying to take sort of object-oriented concepts to, in my opinion, the extreme. They just wrap every class that provides accessors, and but the accessors are around just individual data members, so they're not really providing a very useful abstraction. But you wind up with function calls to do almost any little bit of functionality. And yeah, I'm not nuts about that either. I do find that harder to read. And the idea for it is that maybe you could change the data without changing the function calls. But if your function calls are really just tiny wrappers around, get this member of the class, set this member of the class, then they're not really providing much abstraction anyway. So if you change the data, you probably have to rewrite the class anyway. So yeah, thanks for that question. It's a good one. Okay, looks like everybody's voted. Let me share the poll results here. And okay, so one person is longing for Python, and you'll get that chance in some upper year courses. The software engineering course 444 will teach you Python if you haven't learned it by then. It's good to know more than one programming language. I like Python. I like C++. So I put that on there just to give some break from C++ for those who are longing for something else. For the code style, 53% of people thought the code style was fair, so not terrible, but could be significantly improved. 12% thought it was poor, had a lot of style issues, and 29% thought it was good. So some minor improvements, but it was overall pretty good. Yeah, so I think that's all in the right ballpark. I would rate this code as fair for code style. So it's not terrible, but there are significant areas to improve it in. I think so that's likely where your TA would assess it as well. And broadly, that's what the class thought, so that's great. Okay, so everybody thought there were improvements possible. What should we do? How could this be made more readable? So just type them in the chat. Let's see. Okay, so Sage is saying we've got too many temporaries. Okay, so Sage has got a couple of good ideas. So first, Sage says that inter 1 and inter 2, that these temporaries are not really paying for themselves. So I got these new names, inter 1 and inter 2, and I only use them to connect up to this function, get intersection position. So Sage saying that's not that clear. I'd rather get rid of the temporaries. And Sage also points out that we've declared these distance variables way up here, and then we don't use them until down here. And then maybe we're using them in this code block. But there's a whole bunch of code here in the middle that doesn't use these dist variables, so why did we declare them so early? We kind of used a large scope that increased our cognitive load. So yeah, I think those are all good points. Comments, okay, so Christian and Lawrence both said, hey, where are the comments? So yeah, this is going to get dinged for sure on comments. Most important comment, so if you can put it in a header file, so if it's your header file that you're writing, then best place to put a comment about what a function does is in a header file. So somebody reading the interface to the function can also read what does it do. In this case, this function header is at m1.h, so you put a comment above here. Basically, the most important comment in code like this would be the comment that says, what does this whole function do? So I'd want to see a comment outside the function saying, what does it do? And if it's in the .cpp, if it's in the .header file, it would just be, what does it do? If in the .cpp file, it'll also say, how does it do it? And then we should have some comments for blocks of code explaining some of the sub-steps. But the most important comment is always the biggest picture comment. So in that case, that would be the comment for the whole function. Yeah, and Turin has a good point. So basically, there's a lot of declaring variables early here. Up here, we're declaring, well, this. I'm declaring a whole bunch of variables and then not using them for a while. So, and that's not the best style. It would be better to push those declarations down to just the parts of the code that use them to minimize our cognitive load, how many variables we have to think about at one time. So yeah, these are all good points. So the very first thing that I would do with this code, though, well, let me point out a couple things they did right. Some of their variable names are not terrible. They're not the best, but a lot of their variable names are okay. But we're going to talk about how we can improve them. So they're also not as good as they could be. They did indent. Okay, so they indented 2 spaces. That's actually done so I could fit it on the slide well. I'd probably indent 3 or 4, but you can see the structure of the code. Now, you're not going to get a lot of marks for indenting properly. You will lose a lot if you don't. This is considered like punctuation. So your code should always be properly indented. If you don't do that, it's equivalent to writing an essay with no capitalization and no punctuation. So it's just considered extremely bad, beyond belief. Always indent. So person has done that. But they didn't put any vertical whitespace in. And vertical whitespace is also useful in showing code structure. It basically breaks your code up into the equivalent of paragraphs in an essay, so that we can see the structure more easily. Okay, so let's put a little bit of vertical space in. So I've put a line here around the ifs before the if statement. I've got these 2 lines are really doing essentially highly related things, getting the 2 intersections that are on a street segment. So we've got a street segment that has a certain ID, so maybe it's 28, and what we're doing is we're trying to find the length of it, and this first if statement is saying if we have no curve points, so it just goes straight from intersection, so maybe that's maybe it's 43, it's just some integer, to the 2 intersections, so maybe that's 58, it's some intersection ID. We're getting what is this length. There's a question of, is the else necessary? I'm not showing it. The else statement is, what do we do if there are curve points? So it's not just a straight line. Maybe I could rewrite this where I didn't do it with an else statement, but here I did it with an else statement. But I'm not going to show you any of that code to keep it short. I'm just showing you what's in the case where it's a straight line. Let's see. So that's what this whole function is doing. This, I put a little bit of vertical space in to show, these 2 statements are very related. I'm just getting the from intersection and the to intersection out of this info structure, and I'm going to put them in these new temporary variables. These 2 lines are very similar. I'm going to get the latitude and longitude of each of those two intersections. I'm going to store them in these temporary variables. And then I find the length, so the call my distance between 2 points function, and then I return it. So the vertical, I mean, I would argue that the vertical spacing did help me here. Did make it more clear. Whoops. Okay. But, so that helps. Put some vertical space in your code. But we still have a lot of function scope variables. And this was flagged by multiple people that this isn't the best thing to do. We should minimize the scope. So this length variable, for example, we declare it, we set it equal to 0, and then we don't use it until way down here. Okay? So that's really not a great practice. It would have been better to declare it down here. And this distance variable is, these distance variables are similar. So we declare them way up here, don't use them down to the else. Okay, so it's better to declare them in the smallest scope where we can. And yeah, my apologies, I've somehow saved my ink marks from the prior tutorial. So what we've done here is we've moved some of those declarations down. So now we've said, let's just declare length here. So it doesn't change code much, we just declare it. And we don't have this big block of variable declarations. Same thing with the distance variables, we've moved them inside the else. So now we don't have to keep so many things in our minds. And does everybody remember the rules for scope? Like when variables come into being and when they disappear? So this is something you would have been taught in 105 and 244. I just want to see if it's straight in people's minds. What's the rule for scoping? How long is this length available? Yeah, so it turns out they disappear once the scope ends. So the rule is they come into being, they're constructed, they exist at the point where they're declared. So length would come into being here, and it's destroyed when the scope ends, which is basically the closing bracket. So this length is only available in this short period of time. This info, because it's declared up here, will be available till the scope ends, which is this bracket. So it'll cover the whole function. So put them in the smallest scope that can handle them. Global variables are one example of this. Global variables they have scope the whole program, and you want to minimize them. So you will need some of those for milestone 1, but you want to minimize how many you have. You will need several. You're not going to do it with one global variable. You can make your code more organized by taking all those global variables and putting them in one class or one structure, so that they're grouped together because they are used in a similar way. And now you see one global variable that is more complicated. There's some multiple things inside of it, but that's another way you minimize cognitive load. Let's see. Question, why do we try to minimize global variables? Global variables increase your cognitive load. They are accessible throughout the whole program. And so when I'm reading this function, if I was using global variables in it, I don't just have to understand this function and the variables that are defined in it. I also have to go find, hopefully you've got some header file that is something like globals.h. And I have to go to globals.h and I have to look at all those variables too, because they're all alive during this function. So you've increased my cognitive load for like the whole program. By minimizing global variables, that helps. By declaring them all in one spot, like globals.h, that helps because at least they're organized. By instead of having a bunch of global variables, like int g1 and double, these would be really terrible global variables. Don't do this. They should have long names. This is 2 global variables. If instead I put them inside of a struct that has a .g1 member and a what do I call this, G2 member, it's better because they're grouped. And now I'll see one variable, one top level name for this structure. Maybe I'll call it struct globals. So that is another way to organize my code and minimize cognitive load. But you start by minimize your global variables. If you have to have them, group related ones into a structure or a class, and give them good names. Okay, so do not use names like G1 and G2. A variable that important that the whole program can see it should have a very descriptive name, and they should have very good comments of exactly what they do. Okay, so it's kind of a digression to globals, but that's important for you to do in milestone 1. Okay, so scoping. Let's move on to variable naming. So some of these variable names could be improved significantly. I've got these inter1 and inter2, and I've lost a bit of information. I actually knew which end of my street segment was the from. So I've got a from end and I've got a to end. And that actually matters some. When I get down to the curve point case, it actually matters which one is the from and which one is the to. So it's actually better not to lose that information, and I've obscured it in my variable naming. I knew which one was from and which one was to, but I copied them over to temporary variables called inter1 and inter2, and then I do some work and I put them in temporary variables called lat_long1 and lat_long2. So there's actually less information in those names than there was in the from and to. So that's not great. And a bigger problem is this variable ID. So we've got lots of IDs in your programs. So we're going to have IDs for intersections, for street segments, etc. This is what's being passed into this routine. Find me the length of this street segment. So I should give it a much better name than ID, because these are intersection IDs. So I shouldn't have any names that are just ID. This info name's not great either, right? So it's information for street segment. If you have names like info and val, well, that basically could be any variable. So don't use names like that. Make them more descriptive. Okay, so let's try. We're going to try improving those variable names. The other thing is we have more temporaries than we probably should here. So we have a temporary variables. This was flagged earlier by you guys, but basically this intersection variables are just used to connect to the next function. So maybe that's not the best thing to do. Maybe that's a little longer than it needs to be, harder to read. This length intermediate variable, we just get the result of one function and then immediately return it. So that temporary is not doing much for us either. So let's try to use better names, and let's try to get rid of some of these temporaries and see if it looks better. Okay, let me get rid of this pool. Sorry, I left that up for a while. Okay, so we're going to do that piece by piece. So the ID was probably the variable name that would make me most sad if I was reading your code. So let's change that to street seg ID. That info variable wasn't great, so let's change it to seg info. So I can immediately tell, what is this? Both these now, I know with these two variable names what they are right away. They are for street segments. Okay, I could rename these some of these temporaries, but I also just want to get rid of them. So here I'm going to get rid of well, let me go back here. I've got these two temporary variables, inter1 and inter2. They're not doing much. They're just connecting me to the next function. I'm going to get rid of them. We'll see what it looks like. When we get rid of them, the code looks shorter. I would say this actually does look better. It's not hard to read still, and it is shorter. Short is better if it's not hard to read. We still have these ones. So we have lat_long1 and 2 connecting us to this function, and we still have length that's immediately being returned. So let's let's rename inter1 and inter2 to pause from and pause to, so we don't lose this information about what's the from end and what's the to end. And let's get rid of that length temporary. So the code looks significantly shorter now, and our variable names are better. We can go further. We could take this pause from and pause to. They're still temporaries. We could get rid of them too, because they're just used to pass information into this routine. So let's try that. So here, here's the case where we have the temporary variables. Here's the case where we don't. Where we just paste in, basically take the from intersection, call get intersection position to turn that into lat_longs, and then call find distance between 2 points, because we've done that for 2 different intersections, and we just take those temporary results and pass them right into this find distance function. So here's option A with the temporaries. Here's option B with the temporaries removed. Which one do you like better? So just type in the chat, with temporary or without temporary. I'm going to keep flipping between them. So there's the with temporary case, and there's the without temporary case. Which one's better? And it's a judgment call. There's no real right or wrong answer to this, but which one do you prefer? And I'm not going to move forward until somebody at least takes a shot at it. Okay, so Sage says with temporary, so finds this one a bit long. Anybody else have an opinion on this? Are you with Sage? Are you against Sage? Without. Okay, so Harry likes it better without. Louis likes it better without. Yes, this one is a judgment call. So personally, I prefer this one. Okay, I find this function has now gotten a little too long for me because I have to kind of read it from the inside out. I have to read, okay, wait a second, I got a from intersection, and then I turn that into a lat long, and then I turn that into a distance. So I have to kind of read it from the inside out, and I find that more difficult. Now this code we've just been reading together, so we can probably read it pretty fast, but if I have a lot of lines like this, I can find it hard to read. So I personally find this a bit harder to read. It's more than I would try to do on one line. But one of my former TAs, he liked this better. Okay, so we had that's part of why we put both slides in. It was interesting. I like this one. He liked that one. So there are differences of opinion on this one. I find if you try to do too much on one line, that temporaries become helpful because they're kind of showing your work. You're starting to see the steps and you're naming those steps with variable names, so it does help me understand it. The other reason I like to have not too much on one line is the debugger. So I hope that you're all getting very familiar with the debugger. Maybe you already were from 244, but if not, make the debugger a tool that you use and trust. I use the debugger extensively when I'm checking my code and debugging it. It makes you a lot more productive than just staring at code and putting in print statements. So you kind of want to get beyond that. And in a debugger, the nice thing about this case, where we have 3 lines that are each doing a moderate amount of work, is I can set a breakpoint here, and then I can single step. Well, I can hover my cursor over this pause from, I can type things into the variable display window, I can see all these variables. So I can see what pause from is, I can step one line, and then I can go see what pause 2 is, and I can step one more line and see what they're going to return. So I actually find the temporaries give me this nice named variables and multiple lines that I can set breakpoints on, step through, watch the variables. So it makes me a bit more productive with the debugger. I can still, if I wrote this, by being careful with the debugger, actually stepping into each of these functions and watching carefully what they're going to return, I can still get all this information, but I have to be essentially a bit more careful about exactly when do I step, because the variables don't have names. I have to kind of find that value right before it's returned, otherwise I can't see it. So I find it a little harder to watch things and to step through the code in the debugger when I put too much on the line. So that's why I prefer the previous one. Okay, so, and this is true of code style, kind of like essay style. There are differences of opinion when you get into fine detail, and that's fine. Here's our code before, and here's our code after. And hopefully you all agree that the after code is significantly easier to read. It's shorter, has better variable names, it's more nicely structured with vertical spacing. The original code wasn't terrible, but this new code looks very clear. So that's what you're shooting for. You're in a team of 3. One of the best ways to get better at writing code that others can read is get feedback from your teammates. So you wrote a function, teammate wrote a function, each of you goes through and says, here's what I like about this, here's what I don't. And that feedback makes you much better at understanding what is easy and hard for someone else to read. And you adopt best practices from each other. You're basically peer mentoring. Okay, let's talk about comments. So comments should focus on describing why. So you want to, it's the big picture that's always the hardest to get. So describe the overall structure of your program and data structures. Describing data structures is really important. So let's take global variables. I talked about how it's best to minimize them. Then the ones that you have, try to, if they have similar lifetimes, like they're created at the same time, they're destroyed at the same time, they're used in a similar way, group them into a structure or a class, and then comment them. Okay, so data structures that you created, global variables you created, they should have comments explaining exactly what they do. If you can figure out the data of a program, you can usually figure out how to modify it. If you can't figure out what the data means, you are really lost. So make sure you comment your data structures. and that includes for sure your global variables. Describe why design choices were made. So like, why did you do it this way? That's not obvious to the person reading the program. What's the goal of the following code? So this function, what does it do? If you have tricky or complicated algorithms or special cases, comment them because they might trip up someone in the future. Before you do that though, think about whether you can handle that special case or whether you could make that tricky algorithm simpler. Maybe there's a good reason it has to be tricky. It's the only way to do it fast. Okay, then comment it. But if there isn't a good reason, just try to write it to be simpler and easier to understand. Don't leave commented out code in your project. So you had some code, now you want to get rid of it and use this new code. Just make sure the old code is committed to Git, so there's a record of it, and then delete it. No one wants to be reading code that is not actually used. They're not going to bring that code back, or if they do, they will go to Git and get it. Don't translate code to English. So we don't want to see comments like this. You have for, int inter ID, and so on. And have a comment above that that basically says like for loop over intersections. I can tell. So I can tell it's a for loop because I know how to read C. And you gave me a good variable name, so I can tell it's an intersection. It's over intersections, so I don't need this comment. Now there might be a higher level comment you could write that is for every intersection in the map, we are going to compute the street segments that are connected to it, something like that. Okay, that gives me what is the following block of code's purpose and overall structure. That comment is useful. A comment that just tells me it's a for loop over intersections is not useful. I can tell already. Okay, duplicated code. You don't want to have code that's duplicated. It probably can be extracted into its own function, and then your code will be shorter and easier to maintain. And in addition, when you have duplicated code, the usual way you get duplicated code is somebody wrote a block of code, and then that person or someone else copied that block and changed the variable names because they recognized that block of code basically did what they needed, but it was using the wrong variables. So what they should have done is put it in a function. But instead they copied it and changed the variable names. And that's a common source of bugs because they often don't remember or don't figure out all the variable names they need to change. Okay, so here's an example of that. So what do you think of this code? Can you understand this code well or not? Let me give you a little bit of context. So this code is going through all the street segments. So we got this street segment ID, and we get some information about the street segment, and we put that in a not very good variable name. We call it SS. Not a great variable name. We shouldn't have done that. And then the comment's telling us some of what we're doing. What we're trying to do is we've got a certain street segment ID. Okay, so maybe it's 28. And every street segment has a from intersection and a to intersection. So we've got the from intersection, and we've got the to intersection, and we're calling those SS from and SS to. And we're trying to build up, what the purpose of this for loop is doing is it's trying to build up a vector for every single intersection of the street segment IDs that touch it. So related to the function that we wrote last week in tutorial. So we've got a bunch of street segments touching from, we want to get the IDs of all of them in the vector. And we don't want duplicates. So the code says, make sure the ID is not a duplicate for SS from intersection ID. It calls a function called find. That's part of the it's a templated function from the standard library. It basically takes a starting iterator and an ending iterator and something to look for. So what we're doing is saying in the vector for the from intersection, go check if we've already got this street segment ID. If it wasn't there, okay, so we got the find basically returned the end iterator, meaning I didn't find it. Then we want to put it into the vector for the SS from intersection, and we'll use the pushback member function. Okay, so I just read through this code with you. That's what it does. It does what the comment says. Check if this street segment ID is already in the vector that we're loading up for the from intersection, and if it's not, put it in there. That's what all that code does. Okay? And then we can read the comment here. It says, make sure the ID is not a duplicate for the SS2 intersection ID. Okay, so we're going to do the same thing for 2. So I kind of helped you read the code. That's what it does. Do you find this code easy to read or not? Are there things that you would suggest could improve its code style? So what do you think? Any ideas on how we can improve it? It's not the best. Okay, this code's not going to get great marks on style. So any thoughts? How can we make this better? Okay, I'm going to erase this over here so I can scribble some more. Use temporary variables to define functions. Now, we kind of have. I mean, this is a temporary variable. That's like the iterator that's returned by this. There's not really a logical place to use temporary variables here. I mean, this is kind of the simplest I can pass things into it. Start iterator of this particular vector, end iterator of this particular vector. So that means search through the whole vector, and I'm searching for this, the street segment ID. So this standard find call is about as simple as I can make it. It returns an iterator. I check if that iterator is the end iterator, which means I didn't find it. If I didn't find it, I say call pushback. So I can't probably help much. I mean, maybe I could make you might be right if I could make a reference to this, and that might make my code look a little shorter. So you could try that, right? So that might be just something you could do. Although now you've made a temporary that people have to keep in their mind, so I would probably just write it this way. Because this, it turns out, is an important variable. You're not seeing the whole way that we wrote this, but if you remember back to the tutorial from last week, this was actually a global variable we created. So this is an important variable that probably the reader of your code knows, and if not, there's a good comment on it. But yeah, there's a comment from Vicky well, this looks like duplicates. And you're right, this code is duplicated. So that should make you really nervous. Okay, so this code is almost identical. And that fundamentally makes it harder to read because I have twice as much code to read. So I don't want to do that. So we should extract this duplicate code into a function. The other thing to notice, which is left over from the prior tutorial, is this was copy and paste coding. So we're doing something for the from intersection, and you'll see all of the indices here are SS from. Okay, that's the intersection whose data we're updating. And then if you look down here, it's the same, except all this code's identical, except we changed the SS froms to SS2, so that's why it's duplicate code. And we actually forgot to change one of them. That doesn't make any sense, right? We're checking, is this street segment already in the list of street segments connected to street segment 2 or to intersection 2? And if it isn't, then we're going to add it. But we added to the wrong vector. We actually added to the from vector, which doesn't make any sense. So that's a copy and paste error, and it's another reason you avoid duplicate code. Okay, so we can make this a lot better by making a function. The function would basically just be one copy of what I just showed you. It's better because the code looks shorter now. I just call this insert unique function. It's also better because I've got a meaningful name. Okay, this insert unique, that name tells me what it's doing. Put it, and I should have a comment at the top of that function explaining what it does, but it basically puts a value in a vector as long as it's not already in that vector. So when I'm reading this for loop, this is probably all I need to know, right? It's going to be put in if it's not already there. I don't need to read through this more complicated code. So you've helped me. You give me a higher level of abstraction. So a lot better. What about the comments? Okay, so read these two comments. Tell me whether you like the comments or whether we can improve this. So what do you think? Can we make these comments better or not? Okay, yes, I see can be better. Sage says combine them into one. And yeah, I think that's a good idea. So if you read these comments, they're identical, except one says, well, make sure the ID is not a duplicate for the SS from intersection ID. And then the other one is identical, but it says SS2. So it's kind of repetitive. They're a bit wordy. And to be honest, this doesn't even say exactly what I really did. It says make sure it is not a duplicate. In fact, what I'm doing is inserting it if it's not a duplicate. It's not quite the same as making sure it's not a duplicate. It's not. So I can write a more clear comment, could be shorter, and I don't need to write the same comment twice. So again, I'll use my vertical spacing technique to say, okay, these two things are doing basically the same thing. Let's group them with no vertical spacing so that we can see they're doing the same thing. Let's put one comment that says add street segment if it's not a duplicate. So this is a more precise comment. It didn't say check if it's a duplicate. It's like add it if it's not. And it covers an entire block of code, which makes it easier to understand. So that would be better. All right, sorry, so I've got some stray marks again. So let me just conclude by saying, key principles. Good code style reduces your cognitive load. You don't have to keep as much in your head. And you do that by minimizing the number of variables, minimizing their scope, using functions well. Didn't talk about this, but grouping related variables into classes helps with that. All of those are techniques to remove reduce your cognitive load, how much stuff you have to keep in your mind. You want to have short functions, good variable names that are descriptive, limit your variable scope. You need comments, particularly giving you the big picture. Okay, what's the overall structure? What's the goal? Why did I do this? How do my data structures work? Especially data structures that have big scope. So global variables have to have really good comments. Don't duplicate code, and having short functions really helps you avoid duplicated code because it's much easier to reuse a short function. It has basically one purpose. Okay, there's a lot written about code style because it is so important. So basically every high-tech company now writes lots of software. It's a huge investment. That software has to be maintainable. You have to be able to enhance it. If it's not well written, the style is not good, it's not going to age well. It will gradually become unmaintainable, which is an incredible loss for companies, academics, anybody writing software. So there's lots of books about how to write clean, readable software. Lots of online resources. So Google has a nice style guide. C++ is one of the 3 languages that Google uses to write their infrastructure in. So they actually only use 3 languages for core infrastructure. And each of them has a style guide. So this is the one for C++. There are a lot of good suggestions in here. It's more detailed than you need. So it goes through all sorts of details of C++ and what's good and bad if you do it this way or that way. So don't feel you have to read this whole thing. But if you want to know lots about C++ code style, feel free to read it. It echoes a lot of what we talked about and more. So here, for example, it talks about short functions, and they're also, Google's pragmatic, which I think is the best approach. So it says, you want small and focused functions, but they recognize that sometimes long functions are appropriate. They basically don't like to see them longer than 40 lines. But there could be some cases. The cases where a longer function is not so bad is when it's like sort of straight line code. There's not much branching. It just kind of does a bunch of stuff. So yeah, so this is a useful resource to go read. But as I said, there's more in here than you will certainly need in this course. We're not very focused on, virtually every company has a coding style guideline. And they'll all agree on these basic points that we've talked about. Sometimes they talk about more detailed things, like students will ask me, is it better to use what's called snake case, which is something where you use underscores, inter from, or should you use what's called camel case, which is like inter and then a capital F for inter from. It doesn't matter. Both of them work pretty well. So we're not going to be picky about things like that. We want you to follow the kind of basic important rules, and we're not going to be picky about some of these other things that are sort of more stylistic. Different groups may choose different things. And that's all I had for today. I'll stay online in case there are questions, and otherwise, have a great day.